Welcome to our seminar, Modelling Reinforcement in Revit. My name is Lawrence Hooker and I'm a technical consultant here at Symetri, specialising in our structural tools and also our computational design software. Today we'll be looking at the advantages of detailing in 3D, reinforcing a foundation and a column. We'll also then look at reinforcing and detailing a slab. We'll look at some valuable tips and tricks using Revit Rebar, and then we'll finish up with a summary and questions and answers. So, most of us would already be aware of the benefits of modelling structures within 3D tools such as Revit. There are numerous improvements to the way that we design and document a structure, as well as countless benefits to information delivery, coordination, validation and construction. But what are the specific benefits of modelling reinforcement in 3D? As technology and software has evolved, the speed and efficiency of modelling reinforcement in 3D has greatly improved. We can now have dedicated tools to place rebar effectively that remains parametric to its host. Scheduling and drawing are highly automated, which increases efficiency, even with simple rebar layouts. As you are modelling the reinforcement bars in 3D, clashes and coordination issues can easily be seen and resolved directly in the design environment. The digital modelling of the reinforcement allows for you to fabricate complex cages off-site to improve safety, quality and construction speed. The rebar fabricator can then take data directly from the model to CNC machinery using BVBS transfer rather than relying on manual input from paper schedules. Concrete pours can then be defined in the model along with instant volumes and quantities, ensuring more accurate management of material deliveries and much greater control, which in turn minimises waste and reduces cost. The still fixers will have direct access to the 3D images and models, which reduces ambiguity when trying to interpret 2D drawings. When a still fixer looks at a drawing, they just see dots and lines, right? They need to translate these into a spatial 3D model. With a 3D model, they can actually see the bars and fixing sequences instantly. As mentioned previously, cages and pre-assembled units can be fabricated with confidence and virtually assembled to prove coordination. This, in turn, will reduce the steel fixer's work and increase and improve safety. Quality can also be controlled when cages are prefabricated within a factory environment. Okay, so another thing that's happened is we've recently had our outdated 2005 standard replaced by BS 8666 2020. This new edition now includes two new rebar shapes and the totally changes the way that bars are bent and scheduled and how the overall lengths are calculated. Our new Symetri RC template for Revit has all of these additions and revisions according to 8666 2020 included. In addition, we have all of the schedules set up, many tags and detail components to support detailing to UK standards. Okay, so let's now take a look at some reinforcement modelling live in Revit. For this demonstration, we're just going to use Revit and our Symetri RC template. Okay, so I'll just switch across to Revit itself. Okay, so I'll start off by detailing this foundation and column. And before I actually get into that, let's just take a look at the 3D model itself. And you'll notice here that we have the foundation modeled in here. I've also got a kicker actually modeled into that foundation. And we then have our reinforced concrete column sitting on top. Okay, so like I've said, the only technology we're using here is out of the box Revit and a template. So let's begin by placing in some reinforcement into our foundation. So I'm going to start by cutting a section through this. So we can just go to the view ribbon over here. We can then go ahead and select the section tool. And you'll see that I've got a dedicated RC section for this function. If I cut a section through the foundation like this, I can just adjust the depth there, perhaps something like this. And then we take a look at that. You'll notice that our template will actually suppress all of the hatch pattern within that concrete element, and the RC section is automatically categorized into a folder. So what I'm going to do here is just change the scale factor. Let's perhaps go for 1 to 10 layout here and a fine level of detail. And now we'll start to detail this foundation. Now, I'm going to start off by selecting the foundation, and then I can go up to the rebar command up here. Okay, this is just telling us here that these shapes will not include hooks. That's fine. I can just click OK to that. And now I'm ready to actually put in some reinforcement bar. So you'll notice the context ribbon at the top is showing us all of our relevant tools, and we have our rebar shape browser down on the right hand side here. Okay, I'm just going to expand that rebar shape browser just to give me slightly bigger shape codes in here. And I'm going to start off by placing in a shape code 21. Now, to do this, I can just go to expand to host in this case here, and you can see that it's now previewing that shape. And as I move my cursor around, you can see that the rebar has expanded to the cover lines, which is that dotted green line. In the type selector in the properties palette, I'm just going to swap out this for a H20. Okay, and now we can actually then place in that first reinforcement shape. Now, one of the things that will happen here is when I place this shape, it will just place out a single bar. And of course, in this case, what we want to do is place out a set of rebars. So up onto our ribbon here, I can change the layout rule. And in this case here, I'm going to set this to a maximum spacing of 200. Okay, what I can then do is place down my first U-bar. Right, so let's go back to our plan view in here. And what we're going to do is cut a section in the opposite axes. Now, the quick way to do that, of course, is just to mirror it across at 45 degrees. So it's a little trick when you're working with this type of thing. So we'll just mirror that across with a copy, and there's the next section. We can just go into that section here. And of course, now we can see those bars that we've literally just placed in. Right, so let's put in our second bar now. So we'll select the foundation again. We'll go to Rebar. Revit will remember all of the previous settings. So of course, all I now need to do is place in the next bar. Now, as soon as I do this, you can see a couple of issues here. Obviously, everything is in the same layer, i.e. this second bar here I've placed is clashing with the first rebars. What I'm going to do is I'm also going to tweak and change the actual shape of these bars and the dimensions of the bars. So if I select both of these reinforcement shapes in here, what you'll see is when I do this, you'll see that we've got the A and C leg displayed in the properties palette. So I'm just going to change these both to 750 in here. And of course, that will then directly change the shape on screen. What we'll also do is just move this out of that clash position there. Now, it's not really good enough to do this with Revit. What you need to do is make sure that these bars are constrained together, because what we're looking for is a parametric layout. So I'm going to go directly up to the ribbon here, and you'll notice I have this tool called Edit Constraints. Let's select this. And what I'm able to do here is pick on this B leg of the reinforcement bar. And then I can pick the center line of this bottom layer here, and you can now see that it's constrained together. Now, what's quite clever with this is if I select this two-way constraint icon here, basically now I can change the B1 layer or the B2 layer, and that will then have a knock-on effect to the other layers. So it's bidirectionally parametric, which is really useful. Then I just click on Finish, and that reinforcement constraint is now applied. So I need to actually make sure that these ones are set to 750 as well. And also what I'm going to do is just pull these in a little bit here, because I don't want them right on the edge of the foundation. But of course, again, I might want to constrain these to make sure that they have an accurate layout. So I'll use Edit Constraints again here, and perhaps here I'll just type in -150 for that. And then I can go directly onto the other side over here. And again here from the cover, I'll do -150. Okay, and that's that layout done. And in fact, I think on this side, if I go back in there again and I go to cover, yeah, I'll make sure it's from cover this time, -150. Okay, so I can click on the green tick, and you can now see that layout is complete. Right, but let's now take a closer look at what might happen if things change. So let's say that I want to change the diameter of the bars on the bottom layer here. If I go to my type selector and I make these H25, you can now see that it's forced that second layer or that second bar to move up, yeah, because obviously the diameter of the rebar has increased. So that's the constraint coming into action there and helping us with this design. Okay, So I'm just going to go into the 3D working view here. And what we want to now do is actually see that reinforcement bar, of course, in 3D. And the way to do this, if I put a window around everything here, I can go into the filter tools, and I'm just going to make sure that I've got my reinforcement bar selected in here. And then in the properties palette, we have a special tool here called View Visibility States. And if I select this, this allows us to control how that reinforcement acts within this view. So you can see here, I have my 3D working view, and I'd like to view it unobscured. Of course, if you think about it, the reinforcement bar is inside the concrete, so I need to actually be able to look through the concrete there. And also I want to view this as a solid. Okay, and then what will happen is we'll then be able to see our reinforcement bar as shown here. Now you can see, again, I need to actually make some adjustments to the second layer of rebar in here. So once again, I'll just roughly nudge these into position with the Revit shape handles there. And now, even in 3D, we can use edit constraints. So you can see over here, we're currently going from the edge of the concrete, but I'm going to go from the edge of the cover again in here. And again, I can then just say -150. So that's got exactly the same layout as my previous layer in here. And then we can go and pick on the next face over here, the next leg of the reinforcement bar, which is this one here. Again, we've just got to make sure that it's going from the cover in this example, and then -150. Okay, so that layout is now complete. Now, before we actually move away from this, what I'd like to really do is be able to actually understand these layers a bit better. And also when I start to tag and detail the rebar, I'd like it to be able to recover those layers. So I'm going to select the B1 layer, which is this bottom layer here. And if we take a look into our properties palette over here, you'll see that we have some extra shed parameters set up. And here I've got NV Rebar Placement. So there, I'm going to type in B1. Right. And then I'll go to the second layer of bar in here. So let's go and select that. And these ones here will be B2. Okay, like so. Now, once we've got something like that set up, we can then start to look at things like filtering. So if I go into visibility graphic overrides in here, and I go into my filters, you can see here, I could go to edit and new, and I can now set up some filters to display those various different layers. So in here, we'll go into B1. So I've just created B1 there. This is going to be relevant for structural rebar. So we'll make sure that that's now displayed in here. And then essentially here, I want to select my shed parameter, NV Rebar Placement is equal to, and then I could say B1. Yeah. Okay. So now if I add that filter in here, we can now set our color up. So perhaps I'd like B1 layer to be, let's say we want that to be red, for example, on the bottom layer there. And we can obviously set up our pattern overrides as well. So in here, we'll have a solid fill. We'll make that red. Okay, don't need to worry about the background color in this example. Not going to worry about the cuts either. And you can now see that we have that B1 layer colored up. Now, what's quite nice is if you want to now do a B2 layer, which of course we will do, I can just go to edit and new, select that filter, duplicate it, which is nice and easy, rename that in here. That's obviously now going to be B2 in this example. And then of course, I just need to change the parameter to be equal to B2. Okay, we can then add that filter in just in the same way in here, like so. And then of course I can set up the B2 layer. So in here, we'll perhaps have the B2 layer being blue. And again there, we can set up our solid fill and our blue color again in there. And those filters are now set. So we can now very clearly see our B1 and B2 layers within that foundation. What's good about that is obviously then I can actually switch things on and off. So if I went back into my filter here and I decided I didn't want to see the second layer of rebar in this particular layout, then of course I can really easily just switch that off. Okay, excellent. Now, the final piece of work here is to create our starter bars for the column. So we'll go back into our level 1 plan in here. Okay, and what we'll do is we'll just take this section, move it along a little bit further in here, and then we'll create some starter bars. So the starter bars, we could do it on the third layer in here, or we could kind of try and weave it in with the second layer. I'm going to actually put this on the third layer. So to do this particular task, I'm going to select the host, which of course is the foundation for the starter bar. We'll select the rebar tool. In this example, I'm going to go to Sketch. And what I can do here is I can actually pick the host. And now you can see that I can actually just sketch the shape of my rebar, and then Revit will detect that shape based on the shape codes loaded into my project. So I'm going to use the same H20 starter bar. We'll start it roughly here, and this is just a rough sketch at the minute. Right? And then we'll want the lap to come up through here somewhere. Right, so, and like I say, it's all a bit rough at the minute, so I'll just accept that. Now the key thing is, if I select this bar that I've just sketched in here, can you now see that Revit has detected the shape code automatically? So it knows that's a shape code 11. I can see now that we have the A and B leg dimensioned up in here as well. Obviously I can rationalize those shortly, but before I go too far with that, what I want to do is edit the constraints. Okay, and the constraints are what makes this a little bit more accurate. So what I'd like to do now is constrain this to that second layer of bar. And again, I want that bidirectional. So if I change the bottom bar, the cover or whatever it might be, all three layers, of course, now need to change, which is what's going to happen with that constraint. Within Revit 2022, we can also apply multiple constraints in the same tool. So in here, I want to actually have this up against the cover. So I can just set that to 0, and you can now see that's pulled that bar across. What I might want to do is just have this a set distance away from the cover as well. So we can just do that over here. And again, I might just set that to 150. Let's do negative 150, Lawrence. We want that to go the opposite direction. There we are. And more importantly, I want to actually be able to set the lap on here. So you can see here, it's going from the cover in here. So we'll now set that lap up. So currently we've got a 20 diameter bar. So if we wanted to do a calculation in here, we can say equals, and then we can just say 20 times 40, like so. And that will give me the value in there. And of course, that's 800, but I want that to be a negative in there. Okay, and there's my lap set. So I now know I've got the correct dimension within that rebar. Now, just like you would in any kind of Revit modeling environment, you can go and mirror that across. So I could use the mirror tool just to pop another one of those on the other side, like so. Of course, we can go back into our plan view to coordinate those bars within the column. Obviously, I haven't got any rebar in the column at the minute, but if we just position and pick those two L bars in here, I can go to mirror again and mirror that over the opposite axes of the column. Okay, and there we are. There's our starter bars. Now, what you'll notice when we detail something like this foundation, we're constantly having to select the rebar and make it visible in view. So what I'm going to do is I'm going to run a Dynamo Player script here, and I'll show you how this is built in a minute. It's very simple to actually make these Dynamo scripts work. And what this tool would do is it would automate the visibility of the reinforcement bar every time I click the button. The slight delay at the minute is it's just loading up all of the infrastructure behind here to make sure that Dynamo Player can work. But once it's running, you can just leave it floating here now. So now I'm just going to save view rebar as solid, and we just simply click that tool, and you can see now straight away those bars are solid in the active view. Once again in here, I could then go ahead and start selecting these starter bars. Perhaps something like this. Let's grab all those bars in there. And of course, the layer that these are sitting in is now B3. And just to be kind of a bit thorough with my filters, if I go back into the filter option here and we go to edit new, I can pick B2. This time I want to duplicate that. Let's rename that. And of course, that's now a B3 in here. And just like you saw me do before, I can just select B3 from that filter, add that filter in. Okay, and I think in here, perhaps we'll have the B3 layer. Let's make that a nice yellow color perhaps in there. And we'll do the same for our solid fill. And again, there we can call up that as a yellow bar. Okay, and there's our B3 layer automatically colored up. Brilliant. Okay, and then of course I could proceed through and reinforce the column in a similar way. Now, what I'm keen to do is just show you a little bit more about how all of this is going to actually work as far as scheduling goes. So what we'll do is we'll just minimize our player for the minute, a Dynamo player. In order to schedule this correctly, what we need to do is we need to give this foundation a mark. Okay, this becomes the member in the bending schedule. So in here, I'm just going to call this one P1 for pad 1. Okay, and that's now done. For the column up here, I'll call that one C1. Okay, like so. What I want to now do is select all the rebar inside this foundation. And there's a real nice easy way to do that. You can select any piece of rebar, right mouse click, and you can ask Revit to get all of the rebar in the host, like so. And what we then need to do is assign that to a partition. Okay, so the partitions actually control how the rebar is scheduled and placed out on a drawing view. So for the partition here, I'm just going to call this one DWG1 for drawing number 1. Okay, right. Okay, so let's now switch into our bending schedule. So if we look under the schedules and quantities here, we can see that we've got a bending schedule in here, and I've got a couple of sub schedules in there, which I'll go through in a minute. But you can see now the schedule's placed out. I'm just holding down the control key and zooming into the schedule so you can see it a bit better. And if I go into the filter tool in here, what you can do is you can see that I'm filtering by DWG01 at the minute. So I'll just change that to 1. Okay, and you can now see that that's read and called up all of that rebar. Now, a couple of things to notice here. You'll see that the bar marks have been completely automated. So it's marked up the bar from 0, 1 onwards. And of course, I've got 3 different types of bar in there. We've got H20s and so on. Now, what I'd like to do is just show you that in a proper bending schedule rather than just in a Revit schedule. We'll just get rid of that piece in there. And then if I zoom in, you can see our template also contains this bending schedule set up with weights, because one of the new requirements of the new British Standard is to show the weight at the end of each row and then total that up for the sheet. And you can see our tool is obviously doing that for us as well. You'll also notice, according to the standard, we've also got an additional couple of columns as well. So what used to happen is we used to have E and then R in the same column. And of course, for more complex shapes, that would be a problem. So you can see in the new standard now, we've got E, F, and a separate column for a custom radii that we might want to detail in the sheet. Okay, good. So that's now done. Now, one of the really good things with this is if I go back into this whole layout here and I select my foundation, I can now start swapping it out. So if I went in here and said, right, what would that look like if I said a 1500 by 1500, you can now see that's done. The only thing I forgot to do was obviously constrain these edges to that side, but you can see obviously all of the start bars have updated and everything else in there. If I go back to perhaps a even bigger foundation, let's choose something like that, for example. Again, you can see now that's constrained. As I say, the red bar, I forgot to actually constrain that to the side there, but you can see everything else is updated. Also, another key thing is if I went back to that layer at the start there, and we decided that that wanted to be a slightly bigger bar, let's say a H25, you can now see that all of those other layers have shunted up to accommodate that change. Yeah. So very, very useful. Okay, so let's move on back into the PowerPoint. We'll do a little bit more in there first. So now I'm just going to switch back into my presentation. Okay. So before we go into looking at a slab, what I'd like to do is just go through a couple of tips and tricks with you, and then we'll have a look at the detailing of a slab. So a couple of things to note here. When we're dealing with slabs that are not perfectly square or rectangular, so for example, you might have a radii shown in your slab like I've got on the left-hand corner there, or we might have an angle on our floor slab. Obviously, in this situation, we have to have varying reinforcement going around that curve, or skewed rebar in this example here. So if these are U-bars coming down through the side, you know, obviously they need to align with the main reinforcement. So what we're able to do is use varying range rebar directly within Revit. And you can see what that does is that allows us to actually have varying range rebar in things like beams and slabs and walls and so on. And notice how it's called up in the bending schedule. So it has the same bar mark, but we're just suffixing it with A, B, C, D, E, and so on. But we can also use the varying range rebar for skewed rebar sets as well. Yeah, so it's not just what you'd first imagine it for. If we have a look at this example here, you can see that the main bars of the circular column are placed as a range rather than single bars. This enables the bars to be edited and called up together, okay? And that's a key kind of thing, because what you might be inclined to do is place one of those main rebars and then use something like the circular array tool to pattern that around. But of course, then you'd end up with 12 separate rebars. So using the method here, which is actually using the freeform rebar, we can actually place in that reinforcement bar as a set. And of course, then you can see that when we called it up, Revit will know that there's 12 bars in there. The other key thing, of course, is because it's a set, I can then just go back and say, well, actually now I want 10 bars or 8 bars, whatever that might be. Okay. Right. One final piece of information here, and you kind of saw me use this already, is to enable the efficient and correct reinforcement of foundations, walls and columns, you either need to include kickers in those families and foundation elements, or you use parts, okay? So what you could do is you could have the column coming directly down to the foundation. You could set up a reference plane or a level at the kicker level, and you can use that to actually split the elements down into parts. And Revit fully supports the reinforcement of parts. So of course you can have a big RC wall or a big slab, break it down into parts and reinforce those according to those part divisions. Of course, if you've got things like expansion joints and so on, the parts would also accommodate that as well. Okay, so a couple of little tips and tricks you've just seen there. What we're going to do is now go back into Revit and we'll have a look at placing in some reinforcement bar into a slab this time. Okay, so you can now see we've got a floor slab just shown in here. You can see that I've got a bit of an angle going on in here, and I've also got a structural opening in the slab. So let's look at how we'd first place the rebar in. So I'm going to start by selecting the slab, and here I'm going to use area reinforcement. Okay, for the area reinforcement, we actually want this to cover the whole slab. So I can just select the boundary of the slab there. This symbol here is the major direction of my rebar. And then here, I'll also make sure I'm including my opening in there as well. You can see in the properties palette, we can set up to 4 layers of reinforcement bar. Okay, and each of those layers in here can then have a grade and diameter of bar. In this particular presentation, I'm just going to pop in the bottom 2 layers of the reinforcement here, and you can see it's going in at 250 centers. So let's go ahead and place in those 2 bottom layers in there. And then immediately now, I'm going to remove the area system. Now, this is a bit like exploding out the rebar. And as soon as I do that, you can now see that we have a combination of rebar sets, and in this case, loose rebar. Before I do anything, what I'm going to do is change the layout rule, because maximum spacing doesn't actually make it 250 millimeters between the bars. It'll be approximately, okay? And if you're trying to lap in L bars and U bars and things, it can be a bit of a fiddle. So what I'm going to do here is just now change that layout rule to number with spacing, okay? And then of course we can put in our desired spacing, which I think we said was going to be 250 in there, okay? And there it is. Now, a couple of things. I don't want these bars in here as loose rebars. I want that to be a varying range rebar set. So I'm just going to delete those, and you can see how easy it is to do that. Just sort of sweep a window around it and it's done. What we can then do is start to think about the subdivision of all of the reinforcement bar, okay? So if I look at this, and this is one of the sort of flaws with Revit really, you can see that it doesn't really have any concept of what the maximum stock length of a reinforcement bar should be. So currently I've got 25 meters worth of reinforcement there. So what I can do is obviously I can change this to stock length. So obviously it depends on what you're using as stock length, but in this case I'm going to use 6 meters as an example there. So I'm going to set that to 6 meters, and then what I do is I would now start to copy that, but with a lap. So if I copy this bar across here, let's say that I want a 500 lap here. So therefore the distance will be 5,500. Okay, and then I can just go along here. And of course, the nice thing with Revit is you can just start to type that value in like so. And there's now all of those ranges placed in like that. Obviously now, once I've select those ranges, I can now tell it to be shape code 1 because that's now stock length. And there we go. That's now set and sorted out. If I go to this range in here, I can do a very similar thing. So again, I'll set that to 6,000 in this example. And again, we can go to copy up in here. So I could make that 5,500 again. And another one up here. Of course, that you can see now, the two ranges I just placed out here, so this one and this one, are both stock. So that will be 0, 1. But this one here is not stock because I need to change the length. I could just use the shape handle for that. I could just roughly pull that down. Once again, if I decided I wanted to make that absolutely accurate, I'd go into my constraint, pick on that, pick on the edge of the bar there. And again there, I could obviously constrain that to, and in fact, I don't want to go to the edge of the bar. I want to go to the cover in there. Okay, and I want that actually directly on cover like that. Okay. Now, where we've actually changed the layout, you might find that some of the rebars are ever so slightly outside the slab periphery. So we can just use this tool here to remove either the first or the last rebar in that. Okay, so that can be quite an effective tool so that you're not actually having bars that are outside of cover. Yeah. So we'll just do that here. We'll just remove some of these bars. But there is another way we can do this as well, which I'll show you in a minute, which is basically moving a rebar in a set. And that could be quite useful as well. Okay, good. So we've got some of that reinforcement bar in. You can see I've still got some adjustments to make for the stock lengths and so on. So we'll just change that to 6 in there. And again, I'll set that shape there to 0, 1. Right, so, right, let's now look at the varying range rebar that we need to place in over here. So to do this, we can select the slab again. And you'll see that we've got the same rebar tool that we used earlier on. This time, I'm actually going to implement a new tool, which is called placing the rebar out by 2 points. So this was new to Revit 2022. I can determine the direction of this. So it's going to be a vertical kind of placement in here. Right? And then, of course, we can say I want this to go to the far cover reference, which is obviously the bottom of the slab. And then you can sketch your rebar in. So again, I could type in 250 in there, right, just to get that approximately where we want that sketched in, something like that, just to start with. And then I can just use the shape handles just to manipulate and move that. Because we've got a maximum spacing, you can see that, you can sort of control that how you want. And then we can say, make it a varying rebar set. Now, if I do that and I start to increase the length, can you now see that in this example, I've now got a skewed rebar set. But if I adjust the constraint a bit further down here, now we've got varying range rebar. Okay, so it's simply just that nice little shape handle down here that can control whether it becomes a skewed range like that or a varying range. Okay, so I'm just going to go for varying range in there. Okay, obviously we can adjust the start and the end point of that range. Of course, we can use rebar constraints again to ensure that that is exactly where we want it. And there it is. Now we'd also place in some additional constructional reinforcement as well within the slab. So what I'll do here is I'll just cut a little section through the slab. We'll open up the section, and of course this is where Revit really starts to pay off with the detailing in 3D. You can see now that we're able to now see that and all the rebar in this view. Just for this example, if I wanted to put the top layers in as well, I could, of course, mirror the bottom layer to the top layer. Clearly, I'd probably have to change the laps and so on, so we're not getting a point of weakness in the slab where all the laps are in the same position, but obviously I could adjust that later. And now what we want to do is sketch in a U-bar. And again, I'm going to use some new tools in Revit for this. I'll go to Rebar up over here. This time, I'm going to sketch by 2 points in here. I want this to be parallel to the work plane I'm currently working in and also on the current plane itself. And of course, I'm looking to sketch a shape code 21. And of course, then we can just sketch this in. Now you'll notice I'm sketching it. It's in the right kind of orientation, but I've got a H20, which is probably way too large. So we can just change that to a H12, go on the fly, and then I can sketch that approximately where I want the U-bar like so. And then of course we can go ahead and select that Ubar, and then I can use the properties palettes in here just to change the A and C legs. Yep, so perhaps in here we'll make those, let's make those 600. Okay, of course you could also constrain those as well to again achieve a lap. Yeah. Okay, we can also constrain the layers in here as well. So if I don't want those layers to go right to the edge, yeah, we can obviously pull those back as well. And again, you know, to get that accurate, I could go to edit constraint, as you've already seen me do within the context of a slab. And there I could say, right, well, that's got to be a 150 in there. And straight away, I can do the same thing up over here. Notice I can do it in the same command, which is the new function, negative 150 again. So, and then just simply finish. Yeah. Okay. Now, while we're in here, and that's obviously a layer at the back, let me just do that as well. That's the next range of rebar going further up. There we are. Right, so while we're in here now, we can actually start to show off some of the other detail components that we've got within our model. So we can go to annotate, 2D detail component, and in here, I want to actually place our tick and tag symbol. So I'm going to use this one, full profile at front. Okay, this is something that again we've set up in our Symetri template for your use, and this will kind of lock in to the reinforcement like so. And then what I'll do is I'll just mirror that obviously up to the next area at the top like so. And what we now want to do is place in a couple more at this a different orientation, so we can create similar over there. Again, we can just drop in those roughly, and then of course I can just flip that onto the other side like so. And again, there we can mirror that, yeah, over the top. Okay. Now these ones, of course, will be behind. So you can see here that I've got a little family in there, which will actually push this to the back. Yeah, depending on whether the U-bars at the front or whatever it was. So we'll push those to the back as well. And then what we can do in here, we can also set up the type properties for different bar diameters as well. So in this case here, that wants to really be set up for 14 in there, which is the real dimension of the bar. Let's do that again. So 14 in there. Okay, and you can now see that's done. Right, so obviously onto tagging now. We need some tags to be displayed on this, so we can go to tag by category. And if I just move over my U-bar here, you can see that we're able to then place out a tag. Okay, and that can be now positioned on the tick and tag symbol, like so. And of course, I don't need a leader for that. I can just copy that down to the other leader down there, like so. Let's do that. Let's pop him down there. Okay. Now, also we can adjust these as well. If that's if that's way too sort of deep, which it probably is, I can just use the shape handle just to move that up. Okay. So there's bar mark 22. Let's pull that down, move that down, and there's 22 over there. And of course, I can do the same on this side as well. And I'll show you a little technique we can use here. We'll just get those in the sort of same size there. We'll take this tag and we'll pop it over there. Obviously, that's not bar mark 22 as well. But what we can do is we can pick a new host here. So I can now pick that top bar, and you can see now that's called up the next bar, which is 23. Okay, we'll do the same thing. We'll copy that across. Okay, with that still selected, I'll pick a new host, which is the bottom layer there, and that's bar mark 1 in this example. Yeah, so that's probably a stock bar. Yeah, okay, and there it is. So finally, just to kind of finish off that little detail, we could go to component in here, and I could put in a break symbol just at the end here, just to actually break the slab. And of course, if I wanted to, well, I would want to, I would then need to start to mark up these bars in here as well. So once again, I can make a copy of that, pick a new host, yeah, and there you go. And then we can just copy that, yeah, as required, yeah, across the slab. Okay, good. So you can now see how we would actually start to work up some sort of a sectional detail like that within the slab, directly based on that 3D rebar. But let's go back into our plane on top of the slab, and we'll look at how we can start to present the reinforcement bar a little bit better. So what I'm going to do here is select all the rebar in the host, just like you saw me do before over here. What I want to then do is just recover the center bar from each of those ranges, just as a starting point. Then what I can do is make some adjustments. So obviously there's a lap there and I want to be able to see that lap. So in here, we can say, right, well, let me just display that bar perhaps in there. And then if I come down to this range at the bottom here, we can select it, go back into our Rebar Presentation, select none, and I want to show perhaps that bar, like that. Do the same thing over here. I don't really like the placement of that at all. So I'm going to change that. Okay, and we'll have that bar perhaps shown up over there. Yeah. Again, with this one here, we can change the presentation of that. Again, I'm not particularly liking that, so we can pick on that one instead. Okay, and we'll do one more just so you can see how this is working. Okay, so again, I want to actually then change the presentation to that one in there. Okay, good. Now, another thing we can do, if we look at this, we can see that the bottom layer of rebar is obviously traveling in this direction. Okay, so that's the direction of the bottom layer. What we can do is we can then obviously assign the layers to all of these bars. Okay, so I'll just quickly select all the bars in this direction, which of course will be the B1 layer. And once again, as you've already seen, I can go into my rebar placement and that will be a B1. Like so. And then of course, the remainder of the bars in here will be B2. Okay, so we'll grab all of those. Okay, and that's a B2 as well. Okay, and we'll change that B2. Right. So once we've now got this, we can then start to actually put range indicators on it. And this is something else that's set up within our template. So if we go to aligned multi-rebar annotation, which is what we call an MRA, we can then select the bar, like so. We can place out our tag, just hit the space bar to rotate that where we want, and then we're able to position out the tag. Okay, we'll do another one. So I'll place out a tag in this direction over here. Again, hit the space bar, place the tag, and there it is. Okay, notice it's calling everything up automatically for us. Okay, do another one out over here, just so we've got a few of these placed out. If you get something like that, you can see it's not quite, aligned as I'd want. I can just tweak that with the move command, and that will just straighten that up to make sure it's a bit more presentable. Okay, we'll put in a few more. So perhaps these ones would maybe look a bit neater up the top in this example. Okay, we'll place out a couple more of these. Okay, something like that. And again, I can hit the tab key just to change these a little bit. Something like that. Okay, and we can do the same thing over here. To get these lined up, obviously you could draw a reference plane in there if you wanted to, just to give you something to align to. But there we are. You can now see that we've got those tags placed out there. Now, more importantly, all those bar marks are wrong, okay? Because what I haven't done yet is I haven't given this slab a mark. So I'm just going to come in here and call this slab, okay? Let's now look at the rebar numbering. So I'm going to go into the structure ribbon and I'm going to go underneath reinforcement settings and look at the reinforcement numbering. Now, in here, you can see that I've got DWG1, which is drawing 1, and that's got rebar bar marks from 1 to 3, but then this one is unassigned. So what I need to do is tell the rebar in this slab where it needs to be. So let's do that. We'll select all the rebar. And for the partition, I'm going to call this one DWG2. I'll put this on a separate drawing. So therefore, I might want to start the bar mark again from 1. So if I go back into my rebar settings in here and rebar numbers, yeah, you can now see I've got DWG2. This asterisk symbol here tells me I've got a gap in the bar marks. So I can just remove that, like so, hit apply, and you'll then see now I've got bar marks 1 to 12. Okay. If I didn't want it to start at 1, if I wanted that to sort of be detailing off from 200 or whatever it is, you can just change that to whatever you want in there. Some people like to do that. They have 200 range for slabs, 300 for columns, 400 for beams, and so on. But in my case, I'm just going to keep it simple. That's so. Right. So Now we've done that, if we go back and look at our cross section in here, notice now all those tags have updated. Now, of course, if you think about how you do this in CAD, that would have, you'd obviously have to do all of that manually, and you'd have to go back and sort all that out again, which isn't ideal. So what we'll do here is we'll duplicate the schedule. Yeah, we'll actually make a copy of that schedule in there. I can rename this. So this is a simple project, so I'll just call that Slab in there. What we can then do is go into the filtering in here, and we want to make sure that the filter is now targeting DWG2. And there's our bending schedule. Yeah. Notice in the bending schedule, we also have our varying rebar called up. So in this case, you can see that it's bar mark 10, but then we've got from A through to Y in that example over there. We've got all of our shape codes in there as required, and then obviously our leg lengths of bar rounded up to, the nearest 5 or 25 for the main length of rebar. So again, I could present that on a drawing sheet and all good. Let's take a look, however, at placing an MRA on that slab. So if I go back to level 1 in here, you can see obviously we've shown a single bar in there. So if I create another range indicator, so I'm just going to come along and say create similar in there, and we'll place out this MRA over here. Again, you can see everything is set up in our template. Let's just move that elevation marker out the way. That's a bit unfortunate. Yeah, and there we go. You can now see that we're calling up the bar. Yeah, so 25 H20s, bar mark 10, A through to Y, 250 spacing on B2 layer. Yeah, there it is. Okay, so clearly, just from that simple demonstration of looking at the foundation and the slab, you can see that we've really sort of upped the game a little bit inside Revit. So we're not doing dumb detailing, as I'd called it, in 2 dimensions. We're now actually placing out rebar in 3D and then using Revit and just our Symetri template to provide good details according to our UK standards. Last thing we'll do is I'll just show you a little technique for placing in some bar into this circular column. So what I'm going to do is just set my working plane in there. We'll select our circular column. We'll go to rebar. And in this case, what we're looking for, well, there's been a number of different ways to reinforce this, but what I'd like to do is just go ahead and use some spiral bar, which is 77. Right, we'll select that. And let's make that 10 in there. Okay, so if I go into the 3D view, I'll just call up my Dynamo Player again in here. And what I want to do is view all of that as a solid. See how quick that is. Okay, you can now see we've got all of our rebar actually visualized in there now as well, which is great. So if we now, if we now think about the column itself, you can see there it is. To put the remainder of the rebar in that, I'm going to select the column like so. I'll go to rebar. And because we're in the 3D view, you can see that we get freeform reinforcement. Now, in this particular case, what I want to do is use 20 diameter bars or 20, let's use 20s in there. We'll have a fixed number of these, and I want 10 bars in there. Obviously, we can adjust this later if need be. We can then select the host surface, which is the outside face of the column, like so. Then I can pick the path, which will be the top edge of the column, and then hit the green tick. There's all our rebars placed in. Once again, I want to see those as solid, so I can just run that again. There they are. Obviously, I'll need to constrain those, so I can use rebar constraints just to make sure that they are inboard of the links in there. So if I go down in here, let's say that that's going to be -14. Oops, -14, not 143. Okay, and there it is. And there's our rebar placed in. Now, of course, the beauty with this is if I select that bar set in there, and we now just take a look at what's going on, you can see it's a fixed number and the quantity is 10. So obviously, when I tag and called up that bar, it knows there's 10 bars there. Okay, very good. And the last kind of little tip and trick I can show you is in Revit, one of the things that actually happened was that we were able to actually select reinforcement bar by its schedule mark. Okay. Now, of course, the schedule mark was a very old way of kind of detailing the reinforcement prior to Revit 2015, actually. And you'd have to manually put in your bar mark in here. Well, obviously, the new method is to use the reinforcement number. So that method of selection is really good, but quite difficult to use. So, for example, all those L bars, if I want to select all of those and I say rebar by schedule mark, you can see it just gets everything. So what I've done here is I've created another little Dynamo utility that will set the schedule mark according to the bar mark. So now, of course, if I select that L bar in there, notice here that the schedule mark is the same. So it's P1, so it's taken the pad foundation and combined that with the rebar number. So now if I say select rebar by schedule mark, yeah, it's actually just got those 4 starter bars. And of course, then I can isolate those and, just have a good old look at those. If we go through and do the same thing with the bottom layer of bar in here, again, I could select those by the schedule mark. That's got all of those bars, and then again, isolate the element. Yeah, so that's another good productivity tool that you can make use of.